Dan Janzen, he's been doing his thing in Costa Rica for 35 years. And it's first-rate biology and has made a lot of biological difference. But above that is a whole frame of helping a country, a whole country, take science seriously, take ecotourism seriously, and make it a part of how it thinks of itself in the large scale. And no one I know who's doing both practice and theory around environmental issues, in this case conservation biology, is as much in the mode of long-term thinking. Most of the environmental action is kind of emergency, trying to save habitat, trying to head off invasives. We're trying to make a bad situation slightly less bad and hope for the best. What Dan does is basically say, good, having done that, what about the next few centuries and millennia? And how do you manage that? And that's what he does better than anybody, Dan Janzen.
Now, if you could take this statement and burn it into your conscious operating hard drive, we could just go home. Because really all I'm going to do today is say that. Now, we have had 40-odd, 50-odd now years of focus on the lose-it part, the sort of crisis response that Stewart just mentioned. The barbarians are in the village, the bell is tolling, the red flag is up, grab your bow and arrow, and God, do something to save things now. It's a very human response to things going wrong. Species going extinct, ecosystems are dropping out, the world becoming contaminated, there's too much this, there's too much that. That's what all the focus has been. And what my observation about people is that they only respond to that if the village is really being attacked by barbarians. Because all the rest, they sort of become aware and say, yeah, I know about that. And then they don't do anything. So my focus is on how do you get people to do something with respect to that over there? And I think it's by screaming that the world is going to pieces isn't the way we get people to do things. What I notice is that people hang on to and develop and invest in and think about the things that they use that are useful to us. It's obviously a very selfish sort of way going at the world, but that's what people do. It's Homo sapiens. So my question is, not that piece over there, which we already all know about. Everyone in this room knows about that part. How do we connect this part here to that part up there at the top of this slide? In such a manner that the remaining wildland biodiversity that we've still got is still here 1,000 years from now. Because that's the real goal. All the rest of it is window dressing. All the rest of it is decorations on the petticoat. It's the real substance is that that's still with us 1,000 years from now. At least that's the goal that I set out for me, and Winnie sets out for herself. She's sitting out there somewhere in the top. Now, when you start talking about this kind of thing, yes, we can be theoretical, but very frankly, I think one is a lot more effective, and I certainly feel a lot more effective, talking about the specifics of a place. So we're going to drop into a place. And everything I'm going to say tonight is about a place. The Area de Conservacion Guanacaste in northwestern Costa Rica. If we were talking about Angola, or Kenya, or Indonesia, or Northern Australia, the nouns would be different, but the verbs would be pretty much the same. Okay. So here's where we're going. It's right there. And to give you some sense of scale, San Francisco and the Bay Area to Berkeley would sort of fit in that yellow polygon. This is Nicaragua here, Lake Nicaragua right there. Body Costa Rica, Panama there, and then South America off there at the bottom of that. There. Drop down to sea level. Here's the Pacific Ocean here, the beaches. You go across the flat coastal plain, up to the mountains in the center, over the top, and then down into the Atlantic on the other side. Drop down at sea level, get right down to it. There it is. There's the mangroves of the ocean. Get even closer to it. Here's the mangroves. We go into that dry forest behind it, and this is what it looks like close up. Now we go inland from there, and this sweeps up in elevation to the clouds on the top of the ridge here. And on a cloudless day, up there on top of that ridge, it looks like that. And then we drop down into that forest, it looks like that. And we go over the other side, and it rains all the time. In this sweep, we've gone from Arizona to Maine to Washington to California. And inside that sweep, there are 50,000 species of fungi. There are 100 and whatever it is, a very large number, let's just call it, of insects and spiders and other relatives. There are 960 different kinds of vertebrates, so many of them are little things like this mouse, and then there's a few big exotic things like this spiny porcupine. And then there are people doing things, and what the people are doing in this case is looking at an interaction, which is right there on the ground. Look at it a little closer. It's a large snake having a lizard for lunch, and that is an interaction. And then if we look closely on the lizard, right there, there's another interaction, which are these ticks feeding on the lizard. And if we look inside of one of those ticks, we find a new species of malaria. In other words, this is a very large number of species in a very diverse set of habitats, carrying out billions of interactions. And you say to yourself, well, yeah, that's quite a package. You know, well, it's 2.4% of the world in terms of species, in an area the size of the greater San Francisco and the Bay Area. That's also as many species as there are in all of North America north of the Mexican border. You say, wow, that's pretty hefty for a national park. That's a really impressive national park with all those nice things in it. It's wrong. I don't want you to think that way. What I want you to think of it is this. That's 235,000 species of crops. They're not in nice rows, they're not in bags, they're not in boxes, they don't have labels on them, but there's 235,000 species of crops in that garden. That's out of the world's 10 million or so. And of course the question then becomes is how do we keep these crops in the game for the next 1,000 years? This is obviously a made-up word. But it refers to a very interesting phenomenon. What are these? These are 9,000-year-old spear points. You are sitting, listening to me, like I'm standing in front of a fire in a little village, telling you what I just saw when I went on my little trip today over the ridge to the valley on the other side and came back. You are sitting in the Pleistocene. You are sitting here 25,000 years ago, listening to me tell you a story, a member of your village, and this is what I found out. We are acting, thinking, culturally, genetically, the same animals that made these spear points. And since that time, we've had gardens, in the very literal sense, as part of our behavior, our culture, our social organization, our way of doing things. So instead of saying, gee, how do we get people to believe in national parks? Let's recognize that we have a social phenomenon already, which encompasses a wild area. All we have to do is change the label on the wild area so that it becomes, by its label change, then a friendly, happy member of our society. And it'll still be there then 1,000 years from now, as long as there's a society 1,000 years from now. What are the crops in this garden? Now, the first set I'm going to show you are sort of ho-hum. But I want to get us started thinking this way. If I gave out little pieces of paper and said, write down the crops in the wildland garden that we can build with, you would come up with many of these. I say that as a partial apology at the beginning. What is this photograph of? This is people happy to spend $500 a day to stand in the hot sun taking a picture of a termite nest. I mean that. I mean this very, very literally. What is that? You say, well, that's a book for a bird guide for the birds of Costa Rica. No, that's fertilizer for the ecotourist crop. And if you think that's hyperbole, the ecotourist crop in Costa Rica is worth more than the combined coffee crop, banana crop, and cattle crop together. And Costa Rica is the #2 banana producer in the world. I spend $300,000 of your tax dollars a year in Costa Rica. I'm a high-yield cow. And if you were thinking about Costa Rica has nothing more than a garden in which we are going to grow crops that have a high sale value, creating the whole thing as a giant biological station might be actually not an entirely unsensible thing to do. That school child who learns their biological education in the Guanacaste Conservation, Area de Conservacion Guanacaste, is looking very pensively, very sort of tentatively, at this very large, very wild snake. When she reaches out and touches it, she's a different person for the rest of her life. She's beginning to learn how to read biodiversity. It's converting the snake from a fearsome object, from a roadkill, to something that goes blue in the dark, something bad, into something that's intelligible, something understandable. She doesn't pay in dollar bills at the front door. She pays in votes when she's 22 and 32 and 52 years old. It says up there at the top, the child in us, excuse me, the things which the child in us love remain in our hearts forever. We all know that. Every priest knows it. Every political leader knows it. Now, we all heard about biodiversity prospecting, using the information we have about species and then putting them together into, using tools, physical tools to go along with our information and then putting them together in a bottle full of stuff that then goes off to the drug world to find interesting molecules and make interesting medicine out of them. And when biodiversity prospecting became organized and formalized as a kind of industry, it was widely thought this is going to be one way that we're going to allow the rainforest to sort of pay for itself. A way of income generating which will then be used then to maintain the rainforest. Well, in theory, and in a business school, you can set that up on a model pretty well on a blackboard. It can look very nice. But the reality is that there are problems. And I'd like to illustrate the problems with this. What is this? That is the #1 rainforest drug in the world. And it will be, probably, for a very long time. If you could put a 1 penny tax on every cup of coffee we would make, you could pay all conservation costs and all related costs as well for all of the tropics, for all of the world, forever. We make 3 trillion cups of coffee a year just in the United States. The trick is not finding the rainforest drug. The trick is not doing the research to have it work. The trick is not getting it by the FDA. The trick is getting the 1 cent tax on it. And have that 1 cent tax go in a bucket that pays for conservation. There is no way in hell you could achieve that. So the problem is that you can think of these things as having value and being marketable and treatable by entrepreneurs and all that sort of stuff, but the trick is getting society to turn that penny back into the system so that you keep self-supporting and making that system work as the production of the good, if you like, goes on. We're going to meet this problem later on. Now, what I just described to you are what are called biodiversity services. They're the ones where a species matters. You drink coffee, you drink some other miscellaneous plant, okay? And so on. There are also ecosystem services where collections of species do things that are useful in one way or another. Now, you see this photograph and say, well, there's a nice, beautiful volcano with a beautiful cloud on the top in the middle of the Area de Conservacion Guanacaste, in the middle of a national park. And you go up in that cloud, it looks like that, and if you look closely at the trees in that, you see the water condensing on the side of the tree here. The water condenses in those clouds up there, runs into this river, comes down into this river, is pumped out of the river, and feeds Costa Rica's rice industry, which is a substantial rice industry. That's the water factory. And I mean this very literally. The problem, of course, we have is in the present time, now it's not true in California, I understand this, but in much of the tropics, that water is pretty good. And it just does not then create a charge which then feeds back to keep that forest, keeps that clouds, and keeps that water flowing out of the factory. But it is certainly a good which is a marketable good and something that it could become part of a long-term, continuous funding of maintaining something like this conservation area. What is this? A photograph of the train window between Philadelphia and New York. This is why you live on the West Coast. We all know what the problem is. There's too much carbon up there. So what's the solution? Well, you stop putting it up and you start pulling some down. Well, immediately we've got the ingredients, of course, for a crop. This is a pasture in the middle of the conservation area. This obviously, from the cadavers here, you can see what used to be in that pasture. The cows are no longer there. We buy the land, put it into conservation, and we say, okay, let's do something with it now. Well, the do something, it consists of what happens. I'm going to just turn around and take a photograph in that direction, about a kilometer away, and you grow the forest back on that pasture. You say, well, we've restored the forest. No, you haven't. You've grown 300 tons of carbon per hectare. You've sucked it out of the air, and you put it back in that forest. And also, at the same time, you set it up full of orchids and hummingbirds and beetles and all the other stuff, which becomes a biodiversity industry, which is the insurance. It keeps the carbon in place. That is a crop like growing corn or wheat or rice. And you can arguably charge for it. You know, if the Kyoto protocols had been signed, we would be charging for it. And someday, perhaps, we will be charging for it. The simple point is, it's one more kind of a crop in a wildland area. And as I said before, all the beasts and creepy crawlies in there can become part of the insurance that keeps that carbon there as a forest rather than being cut down. Now I want to move away from sort of what you would have thought of as feasible and logical crops to come out of a conserved wildland, the wildland garden, if you like. This is the Inter-American Highway, 5.5 days from here to Chicago. And it's the entrance of the conservation area. You can see the sign over there on the right-hand side. And what the sign says close up, it's pretty standard for a sign at the front door of a park. It says, welcome, conservation area, a World Heritage Site. The forest is the source of life and development, and keep the fire, don't set any fires. Obviously, there's one hooker in that sign, and it's that. This is the only sign on the front door of a national park in the world that has the word development written into it. It's an easy prediction that 5 to 10 years from now, many will have it. Because if they don't, they're dead. What do I mean by development? Well, I'll show you a concrete example. This is the whole area. Let's say this is from San Francisco to Berkeley over here. And we're going to drop down in this area right there. Right on our north boundary. This is the orange juice you had for breakfast this morning in 1992. All these little orange trees. Well, maybe in California you guys actually grow some of your oranges. Maybe. I don't know if you do anymore. You used to. But now I think probably mostly you don't. And it probably did come from here. This is many, many thousands of hectares. It competes with Brazil for orange juice production. And that's us up there. That's the conservation area there at the top. So here's this, and they're there. So obviously they're very close to one another. That's 1992. In 1996, those trees are producing, and these are the first truckloads of oranges to come out of those orchards. And they go into this giant set of leased machines that eat oranges and pee orange juice and shit pulp. And the question is, what then? Well, here's you take that orange and you extract the essential oil from the outside, which is worth more than the juice on the inside, and you bottle it up like this and you sell it in the supermarket up here as a biodegradable cleaner. So what you have is a peel that's had the essential oils, the stuff that burns your lips when you bite an orange, taken out. Well, when this thing cranked up, I talking to the CEO of this thing, looking, I said, what do you do with your orange peels? He said, well, in Florida, we pellet them and sell them in Europe as cattle feed. And I said, well, why don't you do that in Costa Rica? He said, because the cattle growers here think it'll make the milk taste like orange juice. And so I said, would you give me 100 truckloads? He said, sure. Where? This is the first time we've seen a truckload of orange peels being dumped in the middle of a national park. I bet that one of our 235,000 species of things would like to eat orange peels. So you're seeing the first truckload go down from the Princesa there in 1996. There it is right there with Mooney standing over here as a witness. And so we got 100 truckloads and spread them out over a 400-year-old pasture, totally degraded. This is an African grass, the yellow stuff you see in the background called arago. A totally degraded old pasture, and that's what it looks like 6 months later. Like a parking lot covered with 6-inch deep tar that smells like Cointreau. And it looks pretty horrible. about doing that in your national park, you know, try putting that in the middle of Yosemite and see what people's reaction is, right? You think pretty horrible, and it's about a jillion fly larvae in there churning. 18 months later, it looks like this. There's not a trace left. There's a deep loam soil on the top. All the grass is gone, dead, and broadleaf plants have replaced it. That was the experiment. I didn't know what was going to happen. That was the experiment. And the work through is this. These are fly larvae that normally feed on fallen rotten fruit underneath trees in the forest. They come out of the forest, found this giant fruit crop, and went to work. And really what they are is like little plows. And they're aerating this stuff all the time, so the fungi and the bacteria can do their job inside. And that's really the trick to the biodegradation that takes place. So, we went out and picked out another big area, and now we're not doing experiments, now we're doing management. Pick out a site that's got 23 plant species, most of which are invasive things from Africa and Europe. No topsoil left and no forest regeneration going on. I mean, a disaster, okay? These are chunks of land we bought with the concept of restoring the forest, which you look at and you think, how are we even going to get started? Well, that's what we picked out as a site. This is 1,000 truckloads of orange fields in the middle of a national park. Okay? And as you saw before, this is the exact same photograph 6 months later. Ankle deep, up to knee deep, tar, filled with fly larvae. Every bird in the neighborhood is absolutely stuffed with fly larvae and fly animals. Looks pretty awful. But 18 months later, it's all gone. Not a trace. And we go ahead 4 years from where we are now. This is 4 years ago. This is, well, see, this is taken in 2002. And we're standing right on the edge of the road that goes between the control on the right and the actual management area on the left. So first I'm going to turn your photograph that way. And this is exactly what it looked like when we started. No change at all. There it is. Just covered with, this is an African grass. All the yellowish stuff there is an African grass about this tall. Now I'm standing on a car, and I just turn around and take another photograph that way. There are now 153 species of trees, vines, and perennial shrubs in that site. So 23 or 21, whatever it was when we started. That's one for scale. She's just a meter and a half tall. And the stuff is busy going. It's the forest. You leave it alone and forget it. Unburnable, on its way, with a deep black loam soil inside of it. So you come down here now and you say, well, we'd like to, oh, I'm sorry, look at one thing. So the question is, how are they going to, how's this orange industry going to pay us now for this service? Well, there they are there. These are the orange trees now. It's all this here. That's us above that white line. You notice between the white line and the orange trees are these big chunks of forest like this. There's more orange trees there in the background, as you can see. Big chunks of forest. What that looks like from the air is this. So here we are here. The orange is the oranges, and these are the chunks of forest in between. So we're going, well, it's obvious. You can pay us in chunks of forest for this service. We degrade 1,000 truckloads a year, and you pay us every year in chunks of forest. Fine. And you got it all set up, and here we are, and there's the Minister of Natural Resources and the Director of the Conservation Area, and a couple of technicians, and the owner of the orange plantations, and the 6 o'clock news there. And the President signs off on it, and the British Ambassador signs off on it because they're part of the money behind this orange operation, and da-da-da-da. So, it's a real deal that you do, and fine. Now you come out here now and you say, well, I'd like to see what it looks like now. I'd like to see your next one, and so on. I could take you and show you where we put them down, but there's nothing there. No further. But across the road, there's the orange fields in nice, neat rows being churned by a diesel air-conditioned tractor, which is the equivalent, or is a giant mechanical fly larva. And underneath the plastic tarps are orange fields with rice hulls added to it, and the thing is landscape architect with roads and cars and electricity and the whole package. Very big, fancy biodegradation site. Remember, ours is this. This is us, okay, and that is them. Our budget, $3,000 a year. Their budget, $600,000 a year. Our flies were doing $597,000 worth of work per year. So why is this thing not functioning? Because Us doing this experiment allowed the competing orange juice company 80 kilometers away to take our orange juice company to court, to the Supreme Court, for having sullied a national park. And they won. So the Supreme Court says to us, you have to cancel your contract with the neighboring orange juice company. Now, there's more complications than much. I'm not going to take the time to go through all the additional complications associated with it. But the bottom line is, when you become industrial, when you move out of the sort of goody-goody, I'm stating Bambi the deer state, and into acting like a modern farm next to other modern farms, you, of course, enter the same social milieu that all the competitive world is always operating in. And we weren't strong enough to be able to handle that. And so that while it's technically and biologically extremely feasible, it wasn't politically feasible, if you like. Okay, here we go. Now, when I say biodiversity development, as in the word desarrollo on the entrance to the conservation area side, that's what I'm talking about. So it's just up there with ecotourism and all the other kind of stuff. So why do we go through all this? You know, I would just declare it a national park and be done with it. Well, the bottom line is, maybe this isn't true in Wisconsin or Minnesota I grew up in, maybe. But in the rest of the world, if you don't pay your own bills, and you don't do things to make yourself a welcome member of the society, you're not at the bargaining table when the decisions are made. And you lose. Just like with the terrorists, they only have to win once. But Homeland Security has to win every time. And we have the same problem. You're thinking, this is going to survive 1,000 years. It can't go bankrupt any one of those 1,000 years. So you've got to set this thing up in such a manner that it isn't depending on the whims of a politician. It's not depending on the whims of Congress at some time. It's not depending on the ups and downs of Silicon Valley. It's got some kind of stability. It's got to earn its own income and keep its own keep in the face of society. Then you have a chance. Then you can stand up and look the other guy in the eye and be an equal negotiator across the table. Because you're a farmer like they're a farmer. But we're doing all this, and we can't ever afford to let side of it, to keep the biodiversity in the game. It is not an entrepreneurial game like starting a factory or a company where you can make yourself real rich, retire, dump the company, and forget about it. That isn't what we're taught. That's not the game we're in. We're acting like that, but that isn't the game we're in. We're in the game for the long run. That these things are still there 1,000 years from now. So we are being commercial, we are being entrepreneurial, but there's this funny little disclaimer behind it that isn't necessarily present in normal human entrepreneurial behavior. So what are the mechanics of this? How do you carry out this? Well, some of it we already talked about, but let's get a little deeper. You need three things. You need to have management. The people who carry this out have to be bioliterate. They have to understand the biology of the thing. It's just like in the old days, what you have for a bank. You had a guy sitting inside, a guy out in front with a gun. We don't need a guy with a gun. We need the guy inside who understands it. Just like the modern bank doesn't have a guy on the outside with a gun because there's no money in the bank. It's all out there somewhere invested. Okay? The second thing we've got to have is user community who's bioliterate. The ecotourist, the school child, the person who's doing biodegradation, all these different things. The user for this stuff has got to understand it as well, or have to be at least amenable to understanding it. And finally, you've got to have the political freedom to carry this thing out. And that's a very big thing. It's a very big thing, and we paid a lot of energy and time in attaining that political freedom. Because now we're talking about taking a wildland area that's not a passive thing with a fence around it, and a guy with a gun says, stay out. Now we're admitting a new member of society, and that means one more person in the feeding trough. And that means that you are then going to threaten established political and economic interests one way or another. So you've got to have somebody, some part of the system has got to be saying, yes, green light, green light, green light, go ahead. We're very aware of that because we just went through 4 years in which we didn't have that. So what does it look like in actual, warm bodies? There are 100 staff members, roughly, 30s, 97 to 100. These are they, this is them, this is not some surrogates, that is them. That is the entire staff of this operation. They're all resident. All. Nobody's on the payroll, who is the president. It's 2% of the country as a whole, 153,000 hectares of space, and it's 2.4% for the world species. So that's the package that we're thinking about as indefinite survival, no bankruptcy. And as a resident administration, so as a staff and those administrators, as well as the people who do the other kinds of work. And this is a float in the Cattlemen's Parade. The Cattlemen's Parade. Drunk cowboys behind, drunk cowboys in front. And we're saying, we're a farm just like you are. Our daughters marry your sons, and your sons marry our daughters. And we shop in the same grocery stores, we go to the same schools, and our teachers teach all your kids basic biology in 4th, 5th, and 6th grade. And we produce these people from the machete swingers and the dishwashers and the truck drivers and the people who were doing what you and I think of as working class and lower middle class jobs in that agricultural countryside. Instead of bringing in people who've been trained from the outside, you spend the money on training people up. Through formal classes like this, for these parataxonomists, or through apprenticeships themselves. Attaching somebody literally to somebody who already has been through that process, and then they learn. You take him off the chainsaw and teach him how to raise caterpillars in plastic bags. And you produce the next generation. This is not a setup, this is real, that's the parataxonomist road, that is not her daughter, that's somebody else's daughter, playing and putting leaves in bags. But what is she doing? She is seeing adults carry out a respectable job and take home a real paycheck for doing an honorable kind of thing called biodiversity management, instead of all the other things that are role models in the system. And out of 500 of those kids, you'll get the next ministers or professors of biology. Now, what does it really cost to do this? You know, in hard dollars, okay? So we started this whole thing, and that's a big we, but it started in 1966 as the Little National Monument. And the cost up to this time has been $48 million in total. On a per hectare basis, it's $314. On a per species basis, it's $200. And on a per acre, the 4 ecosystems on that is $12 million. So that's what it actually costs. You have to buy it off the shelf. That's the kind of money you would have to have as we've raised to make this sort of thing happen. There's $7,500 in number you in this room. And then, of course, there's been earned income of one sort or another, the gate at the front door and all that sort of stuff. The cost to finish this thing forever, by forever I mean quite literally, keep this thing now a self-organized, self-running, self-feeding system indefinitely for this kind of a size staff. I'm not saying you couldn't have more, but for a minimal, functional, high-qualified staff, we're looking at another, basically, $16 million. That's what it's going to cost, and frankly, that's what I'm trying to raise the money for. And that piece of paper you got out there, and the other details where to send your checks. And in all seriousness, that's the kind of money that has to be put together. One big check or a whole lot of little checks to finish this thing, so that it's still there 1,000 years from now. So all the rest of the machine is in place. Now, what I want to do, you've seen now in this, whatever it's been, 35 minutes or so, a sort of a smorgasbord of different activities that have taken place over the last, say, 15 years in the sort of development of putting together this thing. And each of those things in there, the fire control, the parataxonomist, the biological education program, each of those different things has had a start and then grown and exploded out of that. And I want to now present one start and explosion that's taking place literally right now in the system, and a new explosion that's coming out of this thing. And it relates to this word up here called inventory, which is setting up all those 235,000 species so everybody can use them any way they want. The inventory, as I mean it in this sentence, is put a name on it, figure out where it is, figure out something about what it does, and have a set of rules to get it when you want it. By get it, I mean take a photograph of it or take a sample of it or whatever it happens to be. And then, of course, put it on the internet. That's what I mean for the 235,000 species when I say inventory 235,000 species. Now, if this was a year ago, I would have gone through some of the things I'm going to show you first. But this is not a year ago. This is now. And there's been a transformation in my understanding of where we are technically in the world and what options are now available to carry this whole giant step further. And it looks like this. That's the basic loop. You know, you find the bug out there, you put him in on a table, you take pictures of him, you gather information about him, you put him into a computer, it goes out to somebody's head. 235,000 times. That's what we're talking about as a basic process. And of course, it produces huge blocks of data with collateral information stuck on it, specimens and sequences and photographs and all this by the billions. Now that might sound like science fiction. That's going on right now. We're not anything new yet here. This is still evidence right here in my laptop computer. and other people's. And you go on a website, and you can put a name in, and you can get information, and you say, well, we get a species page about one of those 235,000 species. It's really the same thing on the web. It is just ripping a page out of this field guide. And so far, we're still on very familiar ground. And you get in the species page, it looks like that. And it's got a date, it's got an author, and it's frozen in time. It's just, again, this is like a page out of a field guide, and it's a lot of work. Okay? But you can do it. There's no little wheel has to be invented for this. Now, people immediately, when confronted with a lot of work thing, start thinking about how do we do this on the fly, extracting information from databases and putting it out there instead of handwritings or pages in field guides. And they're pretty straightforward as well. This is, again, no new wheel that has to be described. You type in a Thomas on their website, and you get all the ones from Costa Rica. Bingo, there they are. I mean, that's just pulled out of a database now. That's not a hard-wired thing. And you say, whoops, there's an awful lot of them. I want to compare this one to my hand-lidded, so I'm in the dry forest. So you go into the same thing, and you type in dry forest as well as the genus of Thomas, and bingo, you got the species that occur in dry forest. It makes it easier to compare with the one you got in your hand. So again, we're still on comfortable ground there. And you can even ask, what does the thing eat? And there's all the information about it. This right now on your desktop off a server in Philadelphia, no problem, or in Costa Rica. You're just using a Yellow Pages. It's the same thing. We've been doing it for a long time, except now we do it through Google and we do it on a website. What we've all forgotten is that when you open the pages here, you look up Mandarin restaurants and you pick out the one that says super hot, and you call that one up and say, is all your food super hot? And they say, oh yes, and then you make a reservation to go for dinner. At that point, which we've all forgotten what you really used the Yellow Pages for, was to get that telephone number. You look up Mandarin restaurant, and you just automatically pluck the phone number off of there. What's the phone number for those 235,000 species? Here's the problem. We have literally 100,000 years or more of learning biodiversity as a society, or as certain members of the shaman, the hunter, the certain individuals, the old grandma making tea for the sick kid. We've learned a lot of biodiversity, and we've forgotten a lot of biodiversity. And there's this package of knowledge that sort of circulates. It's getting bigger and bigger and bigger. The computer just gets huge. And there's you right here. And right now, you want to know what that frog is. Because he stuck his finger in my eye, and should I worry or shouldn't I? You laugh. The first scientific paper I wrote in 1963 was about this species, another very similar species of frog that I stuck my finger on and stuck my finger in my eye, and I thought my eye was dead. Okay. This is you. At that moment, you want to know its telephone number. So that you can go to Google and put it in and learn what we know about that frog. You can't, because you can't get his telephone number. There are 15 people in the world who can give you the telephone number for that frog. But they're not standing there next to you in the rain at 2 o'clock in the morning in Costa Rica. They're sitting in the LA County Museum or in the Smithsonian Institution or wherever it happens to be. And yeah, there's a book as big as a telephone directory that allows you to key it out. But you're not carrying one in your backpack. And you don't know all those funny words mean either. And now there's 10 million of them out there. How are you going to connect one of those 10 million names to this frog so you can get to there? That's where the problem is. And we've all forgotten that problem. I've forgotten it, everybody's forgotten it. Oops, sorry. We automatically think, aha, we now have Google, we now have the internet, now we have databases, so we can make the connection right here. From this to here, no problem. But you've forgotten, in order to make that work there, you've got to have the telephone number that goes with this guy. So how are we going to make the link? Well, there's the jargon word. It's obviously an invented word. It may actually become quite familiar, or some substitute for it might come in. And what are we really talking about? Well, let's do it this way. Here you are in your spaceship, and you're landing. And you're going to land right there in the ACG. You look out the window of your spaceship, and very literally, you're looking at 100,000 species. And I mean this literally. That's not hyperbole. That's a photograph in the middle of the ACG, looking out the window, and there's 100,000 species in that photograph. You step out of your spaceship into this forest, and there's 300-400 of them staring you in the face right there in front of you. Everyone has had a name, a telephone number, for the last 50 to 150, 200 years. And you can't put it on any of them. Me, I spent 35 years of my life in this forest, and I can only identify about 10% of what's in that photograph. Yes, there are 2 or 3 people in the world who, if they were standing right there, could in fact maybe name 30%. Now, you can collect it and send it to the National Museum or to India and get a name 6 months from now. But that isn't what you need the name. You need the name now when you're trying to do something with one of those things. Now, in the field, right now, you're going to collect a sample. It just bit you. You just ate it. It's one of your caterpillars is eating it. You're an intensely interested ecotourist. I don't care what your reasons are. You need to know the name now for this, for this, for this, for this. And you can't do it. I don't care how much knowledge there is in that monastery on the top of the hill. I handle that in the forest. 300 to 500 species of moths sitting on this sheet. I can identify every single one of them. And I'm one of maybe 3 people in the world that can. And if this is your light, I'm not going to be standing there by your side to help you know what this is, and this is, and this is, and this is. If you want to sample all of them, or you want to do something with them, or you want to collect a leader up and send them off to Merck to see if they've got an interesting drug in them or whatever, you're stuck. You can't read nature. The whole damn world is blind. It's effectively bio-illiterate. Yes, there are this 0.00001% of us as priests who can read a little tiny fraction of this. But the rest of the world is illiterate. That's the solution. A gadget you buy for nothing, or it's given away for free. You carry it in your back pocket like a comb, something like that. We could put the telephone numbers for 30 million species in a chip the size of my little fingernail. It costs nothing. Take a leg off the bug, stick a leg in the gadget. 1 minute later, one sequence, i.e., one telephone number, for a penny. Buy it at the Radio Shack or get it for free. That is where the solution lies. And I would argue that is what's going to keep these things alive in the long run, is allowing people to view the forest as a library full of readable books. Because at the present time, it's like a person who's illiterate looks at a library as nothing but a lot of nice firewood stacked on shelves. The idea came from this guy over here, Paul Albert, a Canadian professor of molecular biology or genetics, who said, hey, instead of worrying about the whole genome of things, let's worry about how little a piece of the genome can we extract and get a unique signature. And it turns out it's real small. The idea, of course, is analogy with the barcode on a can of anything in the supermarket, or the barcode on a specimen in a museum, like this thing down here. In other words, read a piece of the DNA sequence as if it were a barcode. And then, of course, this leads immediately calling things a barcoder and jargon and barcoding for this kind of stuff that I'm talking about. What gene? This is a mitochondrial gene in an animal called cytochrome oxidase 1, CO1. And you take this little piece right here, which is 1,500 base pairs long, and slice a little piece out of that. There's enough information in 300 to 600 of those 1,500 base pairs to tell every species in the world apart. Technology's real simple. Plastic tube, I'll label it, take a leg off, drop it in the tube, FedEx it to Paul in Canada. A couple hours later, for $10 you have a name. Think about that for a moment. Next time you got a beetle in your backyard that's eating your rose bush, you want to know what it is. You think how much money and time and effort it takes to get the people in Sacramento or the people in the Smithsonian, in Beltsville, to give you a name that you can plug into Google to figure out what it's you're doing. And this is just starting out. This is what one of those sequences actually looks like. Here's the base pairs along here like this, A, C, C, G, G, T, T, A, like that. And that's the signature I'm talking about. Just takes a small piece of that sequence to tell these things apart. So does it work? These are the bats of Southeast Asia. The length of this line is how different this little set of 3 individuals of this species are from this set of individuals of 4 individuals of that species are. So That's a 2% scale up there. So here's 2%, 4%, 8, 6, 8, 10, 12. So this set of species is 12% different from that set of species on that little sequence. You can tell all the species of bats. Some of these days apart from nothing but a little piece of skin. Just a little piece of skin. These birds in North America, same thing. There are about 2% which are confusable. Little plovers that run up and down the beach that you can't tell apart in about 16 other ways as well. Some of those are confusable. They're only 1 or 2% different amongst them. But the vast majority, you can tell, pull a feather out of an airplane turbine, you know immediately what it is. These Saturday moths of Costa Rica. Now notice there's a whole batch of them that are all the same right here. Those are all individuals of the same species from different parts of Costa Rica. Just give me a label. For hundreds of species of Lepidoptera, for $10, a couple hours, I can tell you what species it was. Sounds like magic, it sounds like science fiction, and it was science fiction. It's not anymore. Now, granted, we don't have to use sequences to identify everything. I mean, we all know what a bird book is, and you see, we have to have a feather off a bald eagle to know it's a bald eagle. You think, okay? You just wait a minute. I mean, you know these are white-lipped peccaries. I don't have to have, there's nothing else in the world that's like a white-lipped peccary, so there's no problem. You don't have to get a piece. But what if you're looking at a piece of jaguar shit and you want to know what it ate? You get 2 hairs off one of these guys in the jaguar shit, put it through a sequencer, aha, it ate white-lipped peccary. Now, when it gets out of things that don't look so distinctive as peccaries do, say like this genus Otomers, say, well heavens, you give me that, and then you give me the butterfly, I can put it on here, I can pick out the one that it belongs to, no problem at all. Would you have guessed that this and this are the same species? Would you have guessed that this and this are the same species? Would you have guessed that that pink thing there is the same as this yellow thing over here? No, you wouldn't have. But the sequences would have told you immediately. So like, well, okay. There's some nice cases, but really, most butterflies look like, different butterflies look like different butterflies. How many are there in that photograph? Tell me how many species there are. There are only 3 people in the world, me being one of them, and these all live in my backyard in Costa Rica. And this genus, I don't know what it is, it's 300 or 200, some enormous number of species. No, look just like this. From Argentina to Mexico. You know all of our sequences. Now, just to show you how dramatic this sort of stuff can be, and the bald eagle example I mentioned a moment ago, this is a very common butterfly. Everybody knows it in Central America. South Texas to Argentina. If I turn you loose with a butterfly net in Panama, Canal Zone, now, for half an hour, there's 200 people in this room, 100 of you come back with one of these things. And they're everywhere. It's just a garden, roadside thing, visits all the flowers. It's had a name for 225 years. The strap is full of it. Museums are full of them. Drawer after drawer, and they're totally boring. Nothing interesting about them. Well, one thing. This is a box full of them, mounted upside down, so you can see what the underside looks like. And there they are. One animal. You sequence that box, actually 460 of them, out of that box, from one place, the Guanacaste conservation area. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 species in that box. All hiding under one name for 225 years. One of the best known widespread butterflies. That's like me telling you that there's 12 species of bald eagles. Now, I'm not saying there are 12 species of bald eagles. I'm simply saying that this hid from everybody. Now you say, oh no, those are polymorphisms. Well, these are just genetic groups. And those aren't species. For heaven's sakes, how do they? Well, if you take them and line them up to what the caterpillars look like for each of those groups, look at that. They're all different. You see, most people don't have a caterpillar. They just have the adult flying around. And the adults are dead on identical. The caterpillars obviously are different, and they eat different food plants. This species goes from South Texas to Argentina. You tell me how many species of those Stratopus fulgurator there really are. When you get 10 of them in one place. Now, to do this kind of magic, what do you really need? We need a global sequence library, something that allows us to, we get the sequence from the bud, and you compare the sequence against a library of sequences to know which one it was. Where are we going to get the library? It turns out, what are museums? Now, I've grown up all my life thinking museums, depositories for specimens that we study and work with. I'll have the references for a lot of stuff and things. It never crossed my mind that you build a course like that. That sequence out of all those pickled and dried specimens sitting in a museum. You don't have to have them frozen to minus 70 degrees, pickled in absolute alcohol, treated this way. Just ordinary old museum specimens. Just go down the shelf, chip, 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 like that, and build your sequence library. And in fact, the big museums are now starting this literally as we speak. 2 weeks ago, the Sloan Foundation in New York should put a $600,000 grant into the Smithsonian Institution to set up a secretariat to carry out this process. Not to fund the process, but to carry it, to make sure it happens with workshops and community people doing, facilitating, and all that kind of stuff. To build that library up there. So that when you get this thing in your backyard, you have something to compare it with. And you say, well, wait a minute, there's 10 million species out there, we only described 1 million of them. Yeah, but you know what? 99% of the species you will deal with in your life, and all the kinds of things you might do in the world, are already sitting on a museum shelf somewhere. But we just get that set into a sequence library, and then build the rest of it as time goes on. The second thing we need is to miniaturize what is sitting in Paul Herbert's lab and a jillion other molecular biology labs around the world now, the machinery that you use to do the sequencing. Right now, it's 2 tabletops worth and a half a technician. In other words, how do you take that and squeeze it down into something the size of my home? That's technically doable. It's just the end of the motivation. Okay? But that has to happen. That miniaturization process has to happen to get the gadget that everybody has. So 6.2 billion people are carrying in their back pocket like a comb. So the one time a week, the one time a month, when biodiversity actually matters, they can read biodiversity. And you say, well, who cares? Who cares about identifying all those crazy other beetles and all the little slugs and all that kind of stuff? You will care when your 4-year-old daughter eats one. You will be very concerned at that moment. When you put your hand on one and it stings you, and your hand starts to swell up, and you wonder, am I going to die, or do I just go to die? At the moment it's eating the tree in your backyard. At the moment you think it's an invasive species of aphid introduced from Russia by a bioterrorist. At that moment you will care very much. So it's like reading. When we teach you to read in 3rd grade and 2nd grade, it isn't because you're going to turn into a Shakespeare. It's because now and then you're going to want to read a newspaper, or write a legal document, or write a letter, or use your laptop, or something like that. I mean, we don't know when or how, but we can bet you will. And furthermore, people say, well, who cares about biodiversity? Well, if you went out in a field, a farmer's field in the 11th century, and you asked somebody plowing in the field, do you want to know how to read? They'd say, why? What good would it be to read and write? What would I do with that? That's what those monks up there in the monastery on top of the hill do. Doesn't do me any good. He wasn't envisioning newspapers and legal documents and books and internet and all that other stuff that we use reading and writing for. And finally, there's got to be a toll booth. Either directly or indirectly, or a combination, as we have out there in the world today. Every time you identify a beetle or a plant or a weed or whatever it happens to be, and you have, aha, this is the thing from Mongolia that's only been invading California and now is going to cause a horrible problem unless we kill it right now. Every time you stick that thing in there and identify that plant, I want a penny to drop in a bucket. And that bucket is used then to fund the process that creates the information that you get when you type that name into Google or its equivalent. In other words, what's the good of having a fantastic telephone directory with good telephones and good telephone numbers if every time you call you get nothing? Okay. Something's got to fund the process that's going to take the information we already have, put it in a usable format, and add more information to it. You can see how this is going to go a self-feeding system. Okay? But there's got to be a toll booth. And that's not me. That's some entrepreneurial type who can think and understands that part of the world and builds that into the system. Remember the cup of coffee? We could pay every single conservation cost in the world if you could put a 1-cent tax on it. If there'd been a 1-cent tax built into the cup of coffee from the beginning, we'd be home free. And of course, there has to be someone to call. That's what you get with toll booth. Now, close this off very quickly here. What I'm calling, and I've been talking to you about the last, say, 10 or 12 minutes, is what I call bioliteracy, the ability to read biodiversity. And I think the relationship of bioliteracy to the relationship between wild biodiversity and people is going to go and can go the same way that literacy has been among people. Like I say, 11th century, reading and writing, who cares? We're not in the 11th century. of our quarter, the gadget, is democratization of biodiversity. It allows everybody, from Emily sitting here in the front row, grandpa to the entrepreneur working for Merck, to know what the beast is that they've got in their hand when they want. I think it's analogous to these things. Printing press, Model T Ford, the Kodak camera, cell phones, the Wright brothers airplanes. That's a tall order. What do I mean it's analogous? What I mean is each one of those was a cheap thing made for common people, with the concept that everybody will have one. And they took off, and they produced, oh, I don't think some of you what these things they produced. So at the beginning I said, wildland biodiversity, use it or lose it. That can be translated. You can read it or lose it. Because if you can read it, you will use it. And I'd like to close with this. People say, look, you work in Costa Rica, it's a marvelous place, there's no army, everybody's educated, it's very healthy, it's very friendly, it's all those things. But then everything you do is irrelevant. Because you've got this nice little cocoon in which you can carry out the Guanacaste Conservation Area, the Area de Conservacion Guanacaste can flower and blossom and be entrepreneurial and self-contained and teach people and hire locals and be resident-owned, all that kind of stuff. And that's irrelevant. Because, you can't do that in Venezuela and Angola and Thailand and you name it, across all the disaster cases across the world. My argument is this. The Wright brothers did not pick a blizzard in January in Minnesota to try to fly their first airplane. Their goal was to show that you could go 300 feet without killing yourself. Once somebody did that, and did it repeatedly, the rest of society took that and built it. What we're talking about here is the Wright brothers airplane. Thank you very much.
Thank you. Is this a household purpose that people can write questions? Yeah, that's great. And if I could get another mic, that would be swell too. While Dan gets a drink of water, I'll just mention that next month, the second Friday, we will be back here at Fort Mason, but over in the conference center with David Rumsey, who's done magical things with maps. He's become one of the world's great collectors of American maps, and has technologically figured out how to make them fungible and flexible through time. And it's called Mapping Time. It'll be an amazing talk. Fortunately, one of Dan's friends came up with a question before the talk. This is from Rich Bennell. Are you here? Where's Rich? Everybody's pointing somewhere. There he is.
He's right down there. The guy in Illinois.
Oh, yeah. Gentlemen, when I call your name, just stand up so we can see who the questioner is. There he is. Okay. He says, does all this fundraising stuff interfere with your entomological research? And is it worth it to you?
This is not actually a planned question. This guy is obnoxious and he asks these kind of questions each time I'm meeting. Okay, so it's I didn't know what it was going to be, but I knew there would be one of those questions. Back in 1985 and 86, when Lenny and I embarked on this sort of thing, we were just as hardcore ivory tower as anybody in this room. And for us, the forest was a nice place that we went to and did our stuff in. And that was somebody else's concern to do this kind of stuff. And I won't spend a half an hour going through the process that made the transformation, but as part of the transformation, we found ourselves standing in a big meeting in the UN one day, and it just sort of hit me between the eyes, and I found myself saying to all these well-dressed people at tables with crystal and water on the tables and so on, look, we have spent 35 years of our lives creating a stack of literature, if you like, about science this thick. 350 odd publications. And we could take the next 35 years of our life and do it again. And all the things that we're encapsulating in this stack of literature won't be there. This becomes an archival historical document describing what was. Or we can make the active decision to basically stop 90% of that and do what this project, if you like, that I've been describing up here for the last hour, along with a whole bunch of other people. And we decided at that point that we just made the decision in a very explicit way. We dumped 90% of our research. Winnie put her finishing up her PhD on hold, waited till we had a political election in Costa Rica. We couldn't do anything and finished her thesis at that time. And we just said, okay, yes, this is going to interrupt a huge chunk of what we love doing, but yes, it is more important because the Nature Conservancy and the World Wildlife Fund and UNESCO and the Fish and Wildlife Service and the National Park Service and all the other people who do this as a career, as a profession, is not enough. We have to get out of the ivory tower. I know this sounds like a campaign speech, but it's not meant to be one. We have to get out of the ivory tower and join forces with that process that they're in. And that's what we did. Total naivete, not knowing anything other than we had to do it. Because otherwise, we're in this ridiculous situation where we're going to spend the rest of our lives doing another gorgeous set of papers and winning awards and being applauded and all this kind of stuff, as we had been. And then it's all gone. There's nothing there anymore. And so if you're being hardcore economist on it, you can say to yourself, no. Put your time into making it live forever, and then think about all the other people who are going to then study it and do things with it. And what they will produce will be vastly bigger, vastly bigger than what we can do ourselves, just the two of us, in the next 35 years or more. So that's the answer to Richard's question. Yes, it does interfere, but we don't think it would interfere. We think it was a trade-off. You do one or you do the other. And this was, in fact, working. But we still feel now today, even when we get real depressed and real discouraged, it is, in fact, working.
Brian Fisher. What examples exist that demonstrate that increased use results in increased conservation?
Let me read the question again.
What examples exist demonstrate increased use and use?
In use in my sense. Let me be careful here. There are all kinds of use, obviously. All the cases that I mentioned up here, the orange peels, the tourists, the children, the researchers, that's all use in my terminology. And being able to walk into a wildland area and read everything that's there, that's use. It leaves footprints, but that's use. So you ask what? Well, just to start off with, the $48 million that it's taken to build this conservation area and protect a block of species equal to all of North America is all created by that use. Without that use, this wouldn't exist. So that's the first that's a concrete product. It costs $48 million. You can put it right out on a per species basis. I can't remember the numbers anymore that I figured, but they're in the handout that you've got. But you know, if you say I'm going to buy it off the shelf, you can put a price tag on it. And that use is what gives you the money to do that. Because that money would never come forth as just protect this as it's fruit. I'll put a fence around it, and there it is. So I would say to Brian that the use is all the things you do there, and we have a concrete case of it right here. And I think this kind of concrete case exists already in some small. Why do you have Yellowstone and Grand Canyon and the Great Smokies and Yosemite still? Because you use them. You may not like all those tourists in Yosemite, but you take those tourists away and you will lose Yosemite. You may not like 8.5 million people going through Great Smoky Mountains every year. There's a big highway right through the middle of it, a huge tourist use. You take that away, you won't have the Smokies in 50 years. You take the people out of Yellowstone, you won't have Yellowstone in 50 years. Now, up here, we do different kinds of use than in other cultures. And different cultures are going to use it in different ways. That's certainly true. It has to meet that culture. But I would argue that that use is necessary. No, I'm very unbashful about saying I'll pay 5% to keep 95%. Sure, I'd like to have a park with no roads in it, no Inter-American highway running through the middle of it, no power lines, and no tourists and all that. I'd love to. Man, I would be delighted with wilderness areas. But they don't survive. Society isn't going to give it to you. And the other thing is that we're all sucked into this thing of thinking of wilderness. There is no wilderness in the New World. We don't even talk about the Old World. There is none here. We lost wilderness 9,500 years ago. First wave of human hunters that went through here took out all our megafauna. From that point on, we are severely impacted from the beginning. So there is no wilderness to go out. There is just a certain kind of wetlands. So that 5% that you lose of the footprints of the users and all that kind of stuff, hey, that's just one more kind of insult that we want to add to all the other insults that are already there permanently. You're never going to get your grouse sloths back. You're never going to get your gopher and glyptodons back, and all the things they did. Remember, there were animals walking around here that weighed twice what an African elephant weighs, right here. They're still down in the La Brea tar pits. Our people took them out. It's like going to East Africa machine gunning the elephants. No different at all. So I would argue that the use that we now do is what's keeping our wildland areas of game. And if we don't jack up the use, like I'm talking about here, to be a diverse portfolio of use, you're still going to lose at the bargaining table. But the only thing Yosemite's got to offer for it is it's a pretty place to have your picnic. You are going to lose it someday. I'll make that as a wild-eyed prediction. And like I said, with terrorists, they only have to win once. And you got to win every single time. And that's a no-win game.
A couple kind of technical questions on the bark corridor approach. The COI gene, this is an anonymous question, was chosen. How was the COI gene chosen as the best gene to be used for the bark corridor? And someone also asked, what would you find? This is Rolf. Is Rolf here? There's Rolf waving his hand, smiling. What would you find if you put human samples in the COI test? How diverse are we?
I'll answer the last one first. We're not very diverse. On CO1, we all fall out pretty much, apparently. You go to GeneBank and get human samples, it turns out that we are pretty much all one animal. But at that level, you're just like blue jays or some other thing that is basically one monomorphic population. That's not to say there isn't genetic differences across populations of humans. Of course there is. But on CO1, why I should have explained maybe is that CO1 in your mitochondria is what handles your oxygen respiration. Virtually everybody who breathes oxygen has the same gene. Now, how was the CO1 gene chosen? It was done arbitrarily, to the best of my knowledge, my understanding is it was done arbitrarily because there are other genes you could have used as well. The trick was to pick one, to try to get that sequence from everybody, from every species, from many, many, many species. Rather than use just gene for that one, and this other gene for this one, and another gene for that one, and now your gadget's got to be able to read 3 or 4 or 5 or 7 genes. So it needed to be one gene that you get the sequence from everybody, all the different species on. And the second thing is it needs to be a very common gene. And your mitochondria, you have multiple copies of your mitochondria in every cell in your body. Whereas nuclear genes that are in the nucleus of your cell is just one copy in the center of each cell. So you're limited by it, but you have jillions of mitochondria. So when we make a mummy out of you, or we pull a hair off, take a little piece of skin, there's a jillion copies of the signal, so it makes it easy to get the copy to read out of it. Now that's true for other mitochondrial genes also. And some other genes could have been used. But the point was to pick one of them, and just a little piece of one of them, and try to get that from everybody. As opposed to trying to get the whole genome for a species, which takes a lot more money, a lot more time, a lot more sampling, and so on. And you could do the same thing. If we had the whole genome for every species, you could do it with that. But you'd still only take a little piece for the telephone number. You don't need the social security number, and all your credit card numbers, and your street address number, and all those other things. So no, it's you. Just one of those numbers is enough. If you're using a piece of the sequence out of the molecule.
Okay, here's some questions we can probe a little deeper into the use question. The first from Michael Kramus, looks like. What do you think of the tendency to patent nature? And I'll ask one repeat question from last night when we talked. What do you think about genetically modified organisms and how they play out both in terms ecologically and in terms of use?
Those are two very different questions. Let's start with the first one, the patent one. Frankly, it's very far outside of my area of knowledge. I would say that patenting is a human artifact. It's something. It's a process that we invent as part of our society and entrepreneurial structure. And I'm certainly not, as a sociologist, I'm certainly nowhere near have enough knowledge to speak about that like I can speak about the stuff I was talking about up here. So I'll waffle off of that question and say that I don't have enough understanding and knowledge to have a considered answer to the question of patenting versus not patenting gene sequences and related things of whole organisms and varieties and all that. I can see the logic presented by many people for patenting varieties of tomatoes and cotton and so on and so forth. I can see the logic in that. Just like any other invention of any other machine. When you get down to having things that occur already in nature, I have the same queasiness that you do, but I don't have enough knowledge in that area to have a considered opinion, frankly. The second one is more the question of GMOs, genetically modified organisms. I, like many biologists, come at this from a historical background, of course, that all of society is built on GMOs and has for a very long time. It's just that those GMOs were accumulated over a long period of time through many, many experiments by a slow process and done, shall we say, in manners that mimic the natural process of speciation and variety development. It's just done by some Indian grandmother or some clever shaman who noticed that if you cross this with this, you get the following thing. And we've been building GMOs for a very, very long time. Now we're suddenly building them very fast. And we're building them with odd combinations or potentially odd combinations that we believe are rarely encountered in nature. They did occur in nature, but rarely. Now we have the potential to produce them much more rapidly. And so now we get into obviously a very sticky, very difficult thing, because we are in a position where we could produce organisms which are, extreme nuisances, or more than nuisances, from the standpoint of invasive species, from the standpoint of disease organisms, on competitive organisms. That's all true. And on a case-by-case basis, I'm saying I don't think we can stop them being produced. I don't think humans are willing to stop themselves, let's put it that way. So that I think the question becomes of what kinds of regulations are we willing to accept in our society to have GMOs appear in a more orderly manner under more controlled circumstances, and I'm not the person who is well versed in this entire set of law and international treaties and all the other stuff that would go with that, to stand up here and give you an hour lecture on it. I share the queasiness about it, but at the same time I also am not as bothered about it. As a biologist, I'm not as bothered about it as, say, some people are for whom biology is a little more magical, is a little less nuts and bolts kind of thing as it is as to somebody like me. And so I'm not perhaps as worried about GMOs as some people are, but I certainly wouldn't write them off as, we don't think about GMOs. I think we do, I wouldn't think about it. But I don't have a sort of immediate gut reaction of no. Oh, I want to add one thing about GMOs. They're commonly touted as, but we have to have them to solve the major food problem in the undeveloped countries, the great starvation problem. That is nonsense. We already produce enough food to feed the whole world without a problem. We have a willingness to distribute problem, which is very, very different than a production problem. And if you start making twice as much rice, or twice as much cotton, or twice as many peaches, or whatever it happens to be, that won't solve this distribution problem. So in a certain sense, it's kind of crazy, because we say, well, if India could just make twice as much food, India wouldn't have a food problem. It doesn't work that way. It doesn't work that way. The Green Revolution that I went through as a young man, hearing all about how that was going to solve all the world's problems, and of course it solved none of them, because all we did was make another set of people big enough to eat all the real extra rice that was produced, and it came along with a host of other problems along with it. So that major thing that's always put out there is the GMO reason for doing things. I frankly don't find a very convincing reason at all. But anyway.
Stephen Hill. There he is. How do you explain the relatively enlightened attitude of Costa Rica to conservation, ecology, biomanagement, and so on? And I might add, how does one get many Costa Ricas happening in the world, including even here?
Well, let's go one. There's two questions again. Costa Rica itself is actually, well, any country is complicated for its sakes, but there's a central aspect of Costa Rica that's missed by a lot of people. Spain colonized the New World. Spain and Portugal colonized the New World pretty thoroughly at a certain time, right? And it was Mexico, Guatemala, Bogota, and Lima, the big centers of colonization. And when you have Guatemala as the center, and you go south of Guatemala, you get Costa Rica as sort of the outback in the most all possible sense of outback. It's like the North Slope of Alaska. It's as far from anything as it could possibly be. And in fact, Spain threw out Costa Rica at one point in its history. Literally said, we hereby disown you. You're not even a colony anymore. It wasn't somebody else took it from Spain. It's that you don't exist. And Costa Rica got on his knees and crawled to Guatemala City and begged, please take us back. Okay? They did. The point is that Costa Rica sat there as a whole in the Spanish Empire. And right about the time of the end of the Civil War, between about then and 1920, Europe discovered this hole. And there were masses of immigrants from Italy, France, Belgium, Denmark, England, Germany, the whole package, into Costa Rica. So you've got post-revolution Europe culture coming as a wave into a hole in the Spanish Empire. And the culture you meet in Costa Rica today is this incredible hybrid. It's sort of like all the people who came off the boat in Ellis Island. Except they went into Costa Rica as a whole. And so it's still Spanish-speaking. It's a Spanish colony, but it got these waves of other things. That is all part of the high education level, the throw away the army level, the social security level, the high health service, all those kinds of things. The second thing is that Costa Rica benefited in a very nice way from what we call the peace benefit. They dumped their army. And all the money that went into the army, I think national budget here, all the money that would have gone in the army went to build the universities. So you flipped, instead of buying tanks and guns, you paid poorly paid professors. Okay? So they're very proud of the educational system that created. So that's the second sort of loop in Costa Rica. The third thing is, I'm going to be very careful about how I say this, because it can come across pejorative, but I mean it more descriptive. It's a nation of small businessmen. Everybody is a small businessman in Costa Rica. So it runs the country on a businessman's mindset. And all the love of conservation in Costa Rica is pure economics. And I mean that very literally. If the green belt, which is 25% of Costa Rica, wasn't generating what Costa Rica views as economic resources, it'd be gone in 20 years. I mean that very, very literally. It is not that Costa Rica is a nation of tree huggers. It is a nation that unconsciously, many times in the beginning, with no understanding of why, found itself with a marketable object called the green. And that marketable object, and I wasn't joking when I said the tourist crop is worth more than the banana crop, the coffee crop, and the cattle crop all put together. And that doesn't escape a man whose mindset is running the local grocery store understands that immediately and will vote for anything that relates to that. When Winnie and I first started this, we were trying to learn what ministers are, what governments are, what banks are. And so we talked to these people a lot. And the president, the president of the central bank, the top policy moneymaker in the country, said to us, very literally, I'll do anything to keep the tourists in the country one more day. Well, if that means opening a national park, putting a road through here, putting a building over there, decreeing this to be a national park where people come and see and watch the turtles and eat in the restaurant and stay in the hotels in the process, I'll do it. This is not that he loves turtles, but he can recognize that that is a resource they can sell. And Costa Rica sells it. Now, I didn't say they do it well. I didn't say they're not going to get out-competed by Cancun and Peru and Ecuador. But remember the peace benefit. For a long time, one of the competitive advantages was you could go to Costa Rica without being afraid of being kidnapped or shot or all the other stuff that was happening in Latin America. Costa Rica is now losing that competitive advantage. And they're very, very worried about it. Okay? Now, the other question, how do you get more Costa Ricans? I don't think you get more Costa Ricans. I think what you do is, I would argue that the general ingredients that I'm talking about up here, vis-a-vis the wildland area, of make it an economically welcome and sociologically welcome piece of the society, I think you can do that in any country. I worked all over the tropics extensively for a long time. I'm confident that we could have done this kind of thing in Veracruz, Mexico. We could have done this in Venezuela. We could have done this in Angola. We could have done this in Cambodia or Thailand. Granted, a big war comes through. Of course, that's a rolling rock that trashes everything. But leaving aside those kinds of major perturbations, you can implant this kind of attitude, and it is being implanted in other places as well. It could be implanted, it is being implanted. But it requires you to decide you want to go that way, as opposed to the put the barbed wire fence around it and ride around with a submachine gun way, which is the cops and robbers way of dealing with conservation. Which is a very limited. Costa Rica went through that stage as well. Park guards carrying the carbines, the whole passage. When we arrived in this thing here, there were 22 park guards on their horses with guns, riding around playing cops and robbers with the poachers and the tree cutters and the burners. And we said, we hereby give all those positions back to the government. Wendy and I will go out and raise the money to hire staff, and we'll teach the staff to do something specific. You'll be a school teacher, or an accountant, or do research, or grow trees, or be police. We have 8 police for 2% of the country. You know, the tough guys with dark glasses, the big gun, and radios, and out there at 2 o'clock in the morning running a roadblock on the Inter-American Highway. They're there. They act like police. And they do get people who break laws, as opposed to a sort of cops and robbers like you saw on the Tom Mix TV. And that attitude can be implanted anywhere. I don't see any reason for that attitude, but it requires you decide to do it. And you know, Brian Fisher's sitting down, he has one of these questions. He's sitting here somewhere, and he's taken on Madagascar at the early stage where we were when we were 40 years old. And what it has to do is somebody say, okay, I'm going to do that. And I'm going to win a prize by suggesting a new idea for Venezuela, and then go to Colombia and suggest a new idea for Colombia, and then I'm going to go to Peru and suggest a new idea for Peru.